So we are now going to study apportionment. This is the idea that we have seats, like the seats in Congress, and we need to divide them up among our populations, or in the case of our own Congress, among our states. And we want to give more seats to the states who have bigger populations and fewer seats to the states who have a smaller population, like our House of Representatives. So the apportionment rules are that things that are being divided up can only be whole numbers. We can't divide up half a seat or half of a person. We have to have it rounded to a whole number. We must use everything. Every seat that we have has to be divided up, and we can't use any more than the seats that we have allotted. And then each group must get at least one of the seats that are being divided up. Every state must have at least one representative, so everybody's got to be represented. The number of things assigned to each group should be at least approximately proportional to the population of the group. They won't be exact because we are rounding to whole numbers, but we're going to be as close as we possibly can. And if Group A is larger than Group B, then we expect for Group A to have more seats than Group B, not Group B having more things than Group A. All right, so we are going to look first at Hamilton's method of apportioning. And this was invented by Alexander Hamilton and was the first method by which we apportioned seats in Congress. All right, so let's take a look at this method, but rather than reading off the steps, I'm going to show you an example, and we'll read through the steps as we do the example. So I'll leave the steps up there. Here's our example. A college offers tutoring in math, English, chemistry, and biology. The number of students enrolled in each subject is listed below. If the college can only afford to hire 15 tutors, determine how many tutors should be assigned to each subject. So we have, in math, we have 330 students, in English 265, in chemistry 130, and in biology 70. And we are going to apportion the 15 tutors out to those 4 areas. So I want you to notice the first thing I've done is I've made a chart. I've made a chart with all of the subjects. I've made a column with their population, and I've added up that population, which is very important. And then I have a column that says quota. We'll explain what that is in just a few minutes. A column for the initial proportionment, and a column for the final proportionment. And this table will change somewhat with each method. With the Hamilton's method, though, we will have these 5 columns. Now, let's look at what step 1 of Hamilton's method is. We're going to determine how many people each representative should represent. We do this by dividing the total population of all the states, in this case our states are subjects, by the total number of representatives. And our representatives in this case are tutors. The answer is called the divisor. So you'll notice I put down divisor right here with an equal sign. We're going to find the divisor by taking the total population, 795, and dividing it by the thing that we're dividing up. We're dividing up the tutors. So we're dividing up tutors between our areas. So our divisor is 795 divided by 15. And if we put that into our calculator, that's 53. So our divisor is 53. Step 2, we're going to divide each state's population by the divisor to determine how many representatives it should have. We'll record this answer to several decimal places, and this answer is called the quota. So now we're figuring out this column called the quota. To find it, we're going to take the population of math, which is 330, and divide it by the divisor. So, in other words, 330 divided by 53. And that's the answer I'm recording here. And that answer is 6.2264. So, for my second quota, I'm going to take the 265, that is the population of English, and divide it by that 53 again. And I'm going to get 5. Now, I'm just going to write that decimal out. We'll see why that decimal is important. So it's just 5, but I'm putting those zeros out there for a reason. We'll see why soon. And then chemistry, I'm going to take 130 and divide it by 53. When I do that, I get 2.4528. And then finally, I'm going to take biology and divide it by 53. And we get 1.3208. Now, I don't have to do the total because I would just get my 15 back if I divided the total out. So it's just every single one of my states, or in this case, our states are subjects. All right, now, step 3. Cut off the decimal parts of all the quotas. These are called the lower quotas. All right, so let's do that part. Let's cut off the decimal. So in other words, I'm going to drop the decimal. My initial allocation is just 6 for this first one. Just dropping off this decimal. 5 for the second one. 2 here. And 1 for this last one. All right, so I'm going to add these up. That's what it says. Add up the remaining whole numbers. Okay, so 6, 5, 2, and 1. 11, 13, 14. Okay, I have allocated 14 tutors. Notice it says this answer will always be less than or equal to the total number of representatives, or for us, that's tutors. And that is less than the total number of tutors that we have to allocate. So we've got 14 allocated, but we need to get rid of one more slot. So assuming that the total in step 3 was less than our total number of representatives, and for us it is, assign the remaining representatives, 1 each, to the states whose decimal parts of the quota were largest. Okay, so here's where we're going to look at, we've got 1 seat more to allocate to make it to 15 tutors. We've allocated 14 of them. We're going to look at the decimals back here in our quota. So let's notice that the 6 has a decimal of 0.2264. So 2264 is our decimal. The 5 has a decimal of 0.0000. The 2 had a decimal of 4.528. And the 1 had a decimal of 3.208. Just looking at those decimals, the biggest one is 4.528. So chemistry, because it's got the bigger decimal right here, is going to get an extra seat. All right, so it's going to get that 1 additional tutor. So we are going to give 1 more to chemistry. We're going to keep all the rest of them the same. And we keep the rest of them the same because we've only got 1 more to give away. Now we have allocated all 15 tutors, and our apportionment is done. So, once more, Hamilton's method. First, you come up with your divisor. You take the total population when you've added it all up and divide it by the number of seats that you have to give away. That divisor is divided into every single one of your populations to get the quota. In Hamilton's method, you will simply drop the decimal for your initial allocation. So you're just going to use the whole number portion of the quota. This will be an underrepresentation. Now, if this happens to add up to exactly what you're allocating, you're done right here. But that's rare. You'll look and see, how many seats do I have left to give away? We will give away the extra seat to the largest fractional or decimal portion of the quota. Now, if we'd had another seat to give away, we only had 1, so we gave it away to chemistry, which had the largest decimal right here. But the next largest would have been biology with 3.208. If we'd had another one to give away, they would have gotten an extra seat. If we'd had another one after that, the next to largest would have been math. And then, of course, finally English. But usually we're not giving extra seats away to everybody. All right? Usually it's just 1 or 2 extra seats. That is Hamilton's method. We're going to see more methods, but we'll get to those in the next videos.